Hello, everyone. Amazing to see that some of you, despite the very clumsy title of this session, thought that this would be interesting to spend some time on. And it's my pleasure to spend the next 30 minutes with you all talking about designing mixed reality games for kids with autism. My name is Mark, and I work at a company called Alva Labs in Stockholm, Sweden. And throughout my career, I've worked with different startups, agencies, and global corporations, but that's not really the reason why I'm here today. In 2019, I decided that I kind of need to break out of my daily habits and see something different, learn something different. So I grabbed some stuff, got my backpack, and moved to Barcelona, Spain, not only for the sun, the beaches, and the tapas, but also to do a master's degree in what's called cognitive systems and interactive media. And as part of this, I worked with the Full Body Interaction Lab at that university, which is a research group there. And together with the head of the group, a PhD student, and a 3D modeling student, we were contributing to the efforts of the research group by continuing their efforts in developing games for kids with autism to learn about social initiation. And today I want to run you through how we approached this challenge and how we developed or designed that game, and show you some methods and frameworks that we also looked at along the way. But I want to start by taking a closer look at autism. And to do so, I want you to imagine the following scenario. Imagine you're regularly commuting to your workplace using the local bus. And one day, as you're waiting for the bus and you're sitting at the bus stop, you notice that there's another person who seems to be waiting for the same bus as you. And you come to realize that that same person that's sitting there has been there the day before as well. And the next day, as you're approaching the bus stop again, you see that same person sitting there one more time, or another time. And this time, that person notices you, makes eye contact, and greets you. How would you respond to that situation? Most neurotypical persons would engage in some sort of nonverbal or verbal greeting, since it's considered rude to not at least acknowledge the other person that's there. Individuals affected by autism, however, struggle with exactly these social interactions. Generally speaking, autism represents a very pervasive spectrum of neurodevelopmental conditions. It has a highly heterogeneous phenotype, which means there's a great variety in its degrees of occurrence. And that's why it's often also referred to as autism spectrum disorder, or ASD. Despite the fact that it's so heterogeneous, there are certain characteristics which are particularly common throughout the individuals on the spectrum, which are engaging in repetitive or restrictive behaviors, as well as having rather focused areas of interest. They are, however, also outstandingly good at identifying logic and patterns in games, like certain rules, which makes them really, really good gamers. But they struggle a lot with the conventions that are imposed to them by society, which means they can sometimes fail to initiate or respond to social interactions. They might have an overly literal interpretation of words due to misinterpretation or misunderstanding of context. And that is something that you can also perceive already early on in childhood. And even though individuals on the spectrum can learn to respond to social interactions, they are less likely to initiate them themselves, like our bus stop example that we were talking about before. And as a result of that, they often have troubles in collaborative tasks, which might lead to an overall compromised social interaction in their life, and eventually even to social fragmentation. And this can have an impact on various levels, from friendships to partnerships, but also financial and social dependence on, for example, family or caretakers. And that, in the end, might even limit their self-determination or self-realization. To improve one's social behaviors, no matter if you're on the spectrum or not, research has shown that you need to have an increased amount of social interactions in your day-to-day basis, which is not really a surprise. It's more this no mastery without practice, right? So to get better at social interactions, you need to have more of them. And in consequence, researchers have been dedicating their efforts to develop certain training sessions for kids on the spectrum, which they call interventions. And I'm trying to summarize a bit of the decades of research that have been going on in there to give you an overview of what they discovered. So the first thing that they tried was different times in life. And they figured out that if you start an intervention early on in life, they tend to be more successful and more impactful than when you have them later on in life. Another research stream focused more on why don't we make this more fun and try something that's game-based, like playing, having more playful interactions. And one of the huge successes in that area is Lego-based interventions, so having the children play with Lego. And they even pushed this further by realizing or remembering that kids love technology and they love to interact with that. So why don't we have a early game-based technology-enhanced intervention, which you can imagine as like playing with digital Legos in a sense. This is definitely already a mouthful. And you can see that, or what you can see is that these different interventions, they also have different approaches on how they deal with that issue. And when we started designing ours, we were trying to deduct common design principles from them to see what has been successful in all these different interventions that already have been out there and been created. And we identified 4 more general patterns of how we should be designing interventions or applications for users on the spectrum. The first one was slow motion. So you're trying to avoid any fast movements or fast animations, since these can trigger freezing behaviors or fear within the individuals on the spectrum. The second one is consistency and predictability, which means that there should be clear rules in your application which lead to very foreseeable outcomes. That doesn't mean that the rules have to be easy and super simple, but it means that they still need to be consistent in the way that they're applied. The third point, incremental complexity, meaning that these interventions should start out with readily acceptable interactions that are easy to engage in, and then as you progress throughout the intervention, you gradually introduce more and more complex interactions along the way. And the fourth point, tangible interactions. So giving the children something tangible that they can hold on to functions as a channel for their attention and also as a cognitive offloader for them. Besides these 4 more autistic-focused design principles, we also identified two principles that are a bit more general, which we wanted to guide us through our development process. And these were, on the one hand side, encouraging collaboration, which might be pretty obvious since we're trying to build a social interaction here. So putting an emphasis on creating social situations within our application and also emphasizing the positivity of collaboration, of what impact that can have. And the second one, continuity. So for interventions, it's important that they're not only a one-time used thing, but rather you use them multiple times over time so that you really get an effect from them. Okay, coming back to our interventions overall. Since I was working with the Full Body Interaction Lab, they were trying to give that their own little spin and put their interests into interventions, which means the Full Body Interaction Lab, as the name maybe says, like full body interaction, is focused a lot on embodiment and the natural ways on how we interact with technology. So they ended up with this research stream called Early Game-Based Technology-Enhanced Intervention Facilitating Physical Embodiment. That's why the title is so clumsy also. So what we were focusing on there is how we perceive the world, so how our senses help us perceive it and how we conceptualize it from there. Basically how our body is mediating this understanding of the environment and the world that we're in. And one way that they found out on how you do this, or what can help to do this, is using mixed reality. And let me show you why by introducing you to one of the frameworks that we refer to very commonly, which is called the reality-virtuality continuum. So what you can see here is that we have 2 extremes. So we have on the left-hand side the real environment, like this room that we're in, right here. And on the other hand side, we have virtual environments, which are computer-generated representations of either the real environment or an imaginary environment. And they completely only exist in the virtual realm. So although these are kind of opposite poles that you can see here, they're not mutually exclusive. Instead, there is a continuum between these 2 points of different combinations of the 2. And that is what we commonly refer to as mixed reality. And finding the right spot on this continuum for your application really depends on the context and the goals that you're working with. Let me show you a generic example to make that point clear. So let's say we're trying to build an application to train, or not even an application. Let's say we're trying to train a plane pilot for flying an airplane. Putting them into a real cockpit right away and having them just fly off is maybe not a good idea, and it might lead to consequences that we don't really want to imagine right now. If we jump to the other extreme, the virtual environment, and creating a virtual space where they can practice flying, like these flight simulators that maybe some of you have played on their computers, we might end up in a situation where the trainee is actually missing context of the real cockpit. Like, what does it feel to interact with these buttons? Like, where is that sense of space that you're in when you're sitting in a real cockpit? So most likely you end up building something that's rather in the center of this, where you have certain parts that are augmented or virtual, like the screen that you can see. So we're simulating the flying, we're simulating where you are. But certain pieces are also more in the real realm, in the physical space, where you have this real cockpit with the real interactions with the buttons. So trying to find the balance between that really depends on the context and the goals that you want to achieve. But enough of pilots. Let's bring this into the social interventions realm. We already know putting children on the spectrum at a bus stop and having them talk to strangers to practice social initiation might not be a good idea either. So one of the examples that the researchers came up with is what you can see on the right here. It's an intervention called Echoes. And in this Echoes, a child would be interacting with a screen, and that screen has a virtual buddy on there, which is called Andy. And together with Andy, they can practice joint attention activities like gaze or pointing. And this is a great example of what embodiment is about. So giving them the freedom to interact naturally with their body, focus on their body movements, and have them also engage, have them given the freedom to engage in repetitive behaviors that they might show. It, however, is very focused on the screen. So if we're trying to build a social intervention that is about the interaction between two humans, this screen might only get you to a certain point, but is not the most natural way that you could practice this. So the research institute that I was working with was trying to push that again more towards the middle and find ways of how we can use technology to mediate that experience and put more focus on the interaction between the kids so that the technology just acts as a facilitator for them. But the kids still have an awareness for each other, like where they are in space, the gestures and actions that they might do. And what you can see here is one of the games that our department came up with, which is called Lands of Fog. And in this game, you have two children playing together, one kid on the spectrum, one neurotypical child, playing on a 6x6 meter floor projection. And this floor projection is covered in a dense fog. So the virtual environment is just a very foggy environment. And wherever the children are, they get this little peephole that they can look through, and they can see what's underneath them. And there would be a monster that would be following them, like a monster creature. And whenever the two monsters get close, so the children also reach a certain amount of proximity, the monsters would engage in greeting each other. So they would maybe wave at each other or do some other sense of what humans do when they greet each other. And if you come even closer, the monsters might combine and create a whole new creature. So that was kind of like the trigger that they wanted to set to get the children to move closer to each other and engage with each other. This game turned out to be quite a success story already, but there were also certain pitfalls to it. For example, it was more liked by male players over female players, since they enjoyed these creatures and the monsters in it a bit more than female players. And the whole game was based on a storyline where you would be together collecting keys to open a treasure box at the end, and then after opening a treasure box, the game is over and it doesn't continue. So having this continuity wasn't really given in that game design. There's one more concept that I want to show you, which is called virtual subjectiveness, and that also helped us when we were designing our game to think about certain interactions. So let's start with the example of working with a computer. So when you're at home interacting with your computer, you have an input device, which is usually your mouse or a touchpad, and you have an output device, which is the monitor that you're looking at. And your input device, the mouse, is usually mapped onto the screen, and you can see, for example, the cursor that you would usually see as your logical interface within that virtual environment that you're interacting with. And there's a certain mapping between these two. And this mapping also influences our understanding and how we make sense of this virtual space that we're interacting with. So let's say you move your finger on your touchpad or your mouse just a tiny bit, but your cursor jumps from one edge to the other edge of the monitor. You might get a feeling that this virtual space that you're interacting with must be rather small. If we look at the other end of that, if we change that mapping and you move your finger quite a lot on the touchpad, but your cursor only moves a teeny tiny bit, you might have an understanding that this virtual space that you're interacting with must be actually huge and needs a lot of effort to get onto the other side. So virtual subjectiveness is taking this concept of how we form understanding about space and environment and applies that into the mixed reality realm. So let's imagine we have this virtual environment forest that we're placing you in, and we're giving you a head-mounted display to just sit on a chair, and when you look around, you see this forest. And the only thing that you can do is really look around, so there's no other interaction. So let's keep it simple for the moment. How the virtual subjectiveness and that looks like really depends on how you design it. So we have an input, which is our user with the head-mounted display rotating their head around. And the output is generated on the head-mounted display, so you're seeing a certain viewpoint of that virtual forest that you're in. And you can control that view through your head rotation. And the typical head rotation of a human is 90 degrees to either side. If that's different for you, maybe see a doctor, I don't know. And depending on how you map this into the virtual realm, that really shapes the experience of it. So let's take the example we map this one-to-one, meaning that if I turn my head 90 degrees to the right, the viewpoint in the game also turns 90 degrees to the right. Then I myself might actually feel like I'm literally in this forest looking around. There's no difference in that mapping. But if you change that mapping from a 1-to-1 to a 1-to-2, meaning that if I turn my head 90 degrees to one side, it actually spins a 180 degrees in the application. The experience changes quite drastically, and you might be closer to what an owl is experiencing when they're sitting in a forest. So even though the virtual environment stays the same and we never do any changes to that, the experience has been impacted quite a lot. So these design decisions have a great impact on what you're doing and need to be thought through. But enough of the theory, let's look at what we actually built in our application. If we start with the hardware first, we were basing our hardware setup on the game that I already presented before, Lands of Fog, which was a predecessor from what we've been building at the research lab. And it works that way that you have two projectors on scaffolds, which are projecting on the floor in a 6x6 meter arena. And at the ceiling, you have RGB light sensors, which are used as a position tracking system. So the kids would be equipped with controls that have a certain color ring, like an LED strip, that is emitting a certain color, and that way we could track where they are in the environment. So that was our hardware setup. But since the game came with some pitfalls, we wanted to change the game completely and build one ourselves. And to do that, the first thing that we were looking for was trying to find a theme that we could build around. And looking at typical themes or popular themes within the autism realm, you can, and especially like kids on the spectrum, you find three themes that are very popular. One is dinosaurs, the other one is the universe, and the third one is mythical creatures. And I mean, they're all pretty cool, don't get me wrong, but I think for our application, universe seemed to be ticking a lot of the boxes that we were looking for, since it comes with a certain logic. So if we're looking at consistent rules, etc., we can follow laws of physics, for example, and lean onto those to make sure that we have predictable outcomes and clear rules established. It was seemingly neutral enough to not favor male players over female players, what might be an issue with like mythical creatures or dinosaurs also. And it seemed abstract enough to us to allow us to build in some certain algorithmic, which could create a limitless number of situations and activities that the kids could engage in. So making sure that we have a continuity here rather than just one storyline. So what we ended up with making our story, or basing our storyline on, was this claim of co-creating a universe. So having children progress through the intervention, through collaboration, and the more they would collaborate, the richer the experience should become. And as I said before, virtual subjectiveness is kind of a critical part on how you form understanding of the environment that you're interacting with and trying to understand this world. We also use that concept to try to get an understanding of what we're doing and what is important to us. And in our application, we have two children which are supposed to play the game, one child on the spectrum, one neurotypical child, which would be equipped with this custom input device that we designed for them. And in this case, we were trying to give them some sort of abstract space tool, so it didn't need to have a specific shape that we wanted it to be, that they associated to something. We were trying to really be abstract, that they have a feeling of maybe being an astronaut in outer space, and they can use that tool to interact with that virtual environment that they're seeing and manipulate things, objects in that virtual environment. And for the mapping, we kept this to a 1-to-1. Obviously, we didn't really want them to feel different, like they shouldn't be anything else than what they are. Like the focus is on the social interactions between the children, and the technology is only a mediator in the background. But the representation, so the logical interface that they had in the game, we were quite puzzling around like what does work well, what does not work well. And we ended up with this stardust cloud that you can see here in this picture that would follow them along. So wherever they had their controls, they would see this stardust cloud. And also here we kept this one-to-one mapping to give them the feeling of agency, that they can actually control this cloud going around. And if they get closer to object, it would start sparking like lightnings into the direction of the objects that they're interacting with. So let me run you through one of the typical play sessions that we would have. This is quite tough to see, but there's a circular arena here that you can see. And it's circular to avoid kids getting stuck in corners and edges. That is a quite common phenomena that they just like go into a corner and stay there for the rest of the play session. So with a circular shape, you're redirecting the attention into the center of the game arena whenever you reach the border again. So once our player entered the game arena, in this case, we have this representation of the blue and the red square here. Whenever they enter, we would start opening up what we call white holes, and it's pretty much the opposite functionality of a black hole. So it is emitting something rather than sucking things in. So in our case, these were particle systems, and you could see different colors of particles flying around that area where that white hole was opened. And we used 4 different colors in this arena. So you would have 4 different pools with a different color each. And once a child would step on this white hole, the white hole would actually set these particles free, and they would go to the other player. It's kind of like a sense of a gift to the other player or an invitation to play together. We would then close the white hole so it would disappear, and later in time it would open up in a different location within the game arena. As the intervention progresses, we would shoot different objects like throughout the game arena that were just crossing through, like this comet here or the meteors, which look similar to this diamond that we show here. And when players get close to that meteor and they have particles around them, together that would create a planet. And this really depends on what color of particles they bring in, what amount of particles they bring in, if they have maybe like 2 colors at the same time because the other player sent them 2 in a short time. They could create different shapes of planets and different types of planets, and they would have different textures, maybe certain assets to them like a moon or a torus. And we had a certain algorithmic defined on what defines which state. So there were clear rules in the background on how to create those, but it would be quite tricky for them to figure out what they need to do to get a torus, for example. As the time progresses, we'll eventually reach a point where 2 children would be on these white holes at the same time, which would cause them to emit the particles, and the particles would collide in the center between the 2 white holes. And again, depending on the combinations of particles here, we would either trigger a visual or audio effect or create what we call a star. And each star would come with a certain amount of orbits around it, which would have circular shapes on them, like kind of like a placeholder in shape of a planet. Maybe you see where I'm going with this. Because if players would get closer to these objects, like a planet, the stardust would start sparking lightnings, shooting lightnings towards that planet. But as a singular player, you're not strong enough to do anything. So only if the 2 players coordinate to go to the same planet, or maybe by accident pass the same planet, they would lock that planet in between them, and they would be able to move that planet around the game arena. So once they figured this out, they would be able to carry the planet onto the orbit of the star. They could release it there, and it would start circulating around the star. So over time, they would carry the different planets onto the positions on the star and complete the solar system. And once that solar system is completed, it would implode and open up a black hole, which is a portal into a new level. So the 2 players could go into that black hole and start over in a different level with different colors of white holes, so they can create different planets and different forms, materials, textures. All right, so far so good. We kind of ran through the main idea of the game. There's a bit more to it, but that's like a simplification of what it is about. And once we got to the point that we had this established, we were wondering, like, does this actually work? Like, it's nice on paper, but do kids actually understand how to play this game? And does it do what it is intended to do? And it's usually not a good idea to test with kids on the spectrum right away, since animations or sound can actually cause harm for them. So what you do instead is you try to test with neurotypical kids first. But I experienced testing with kids is quite different to testing with adults. Like, you can't give them a given procedure and expect that they just follow through. Like, they will bend the rules and make it their own, make sure that they can play with their friends rather than just a random partner that you assign them. So you need to be a bit more creative in finding ways on how you can get feedback from them. And I just want to present 2 examples on how we did it. One example is drawing analysis. So after a game session, we asked the kids to paint for us. And the task sounded quite vague, like, can you draw how you played? Which is a very, very open statement and doesn't really put a focus on it, but that was intentionally supposed to be that way so that they could draw whatever they thought was relevant to them, to their experience. And then we went and analyzed these paintings on what are kind of like central pieces of that artwork, what are more in the periphery, and which pieces are actually missing. And that gives you a good indication of what they think is actually meaningful to them or was meaningful to them throughout the game session versus what pieces did they completely forget about. Since we were working with a digital tool or a technology-enhanced tool, we also had the option to track their positions and write a log that would send us the location every second of each child. So we would get an understanding of where did they move, how much did they move, which could create this heat map that you can see here. So understanding how much of the game arena did they actually cover, did they explore the different elements, or did they stick to certain areas within the game arena, which elements did they interact with overall, and also compare that to each other to understand, okay, player A moved in that area, player B moved in a different area, how did that over time change? And one trend that we noticed was that the physical distance between the 2 players actually got closer as time progressed throughout the intervention. So they would start out being rather far away from each other, but they would end up being quite close together. Based on these learnings that we could take from these testing sessions, we iterated the game a bit, changed certain parameters and adjusted timings, and we finally felt ready to test this game with kids on the spectrum. But then, unfortunately, COVID hit in Spain, and things came to more or less abrupt standstill. So the data that we collected up until this point gave us a strong indication that we had a pretty sophisticated intervention here that we would like to test, and also speaking to psychologists confirmed our beliefs that that could actually work. However, there were things left to work on. One thing that we wanted to do was also to include, for example, physiological parameters like heart rate and understand how that is being impacted throughout the game session. Since I left the laboratory, there has been work going on and continuing. Also, what happened last May was that the Catalan Minister of Research and Universities was visiting the lab and playing with the game. So it's actually getting quite some attention now, also from the politics, which hopefully will lead to more funding and extended research in that area. And one of my former classmates is setting up new projects now in the laboratory, which is called the Prosocial Project, which is actually more focused on group activities. So it's not only about 2 players and one-on-one interactions, but also learning about group dynamics. So there are different streams opening up based on what we did with this game. I know this must have been a lot for the last 30 minutes, so let's do a quick recap of what we talked about. Autism is a spectrum, which often causes difficulties with the conventions that are imposed by society, especially when it comes to communication and social interactions. We are always designing on a reality-virtuality continuum, so thinking about your goals and your context before choosing your tech setup is really important. So don't go with whatever fancy tech you have on your desk. Really put an emphasis on understanding what implications this might have. Key design principles when designing for individuals on the spectrum are consistency, predictability, tangible interactions, and slow motion. Design the user's virtual subjectiveness within your application with intention, and don't turn your users into owls on accident. And last but not least, testing with kids requires creativity. So think about what you actually want to know and find unconventional ways in which kids can give you natural feedback for them. If this evoked your curiosity or left you confused, I believe we have some minutes now for a quick Q&A. Otherwise, don't hesitate to reach out on LinkedIn and keep this conversation going even after the conference. I hope you enjoyed the talk.